Alright, welcome everybody. My name is Christopher Ogome. You're welcome to the Chemistry Mastery Academy. Today we're going to be looking at the topic carbon and its compound. Carbon and its compound. Now, basically, when we talk about carbon and its compound, first of all, let's look at what carbon is all about. Alright, so now, first of all, we know that carbon is a group what element? Carbon is a group 4 element. Why is it a group 4 element? It's a group 4 element because it has 4 electrons in its atomos shell. So it has 4 valence electrons. So this is the atomic structure of carbon. First shell has the maximum number of 2. Second shell has the maximum number, has 4 electrons, making it what? A total number of 6 electrons. Now, because of this atomic structure of carbon, carbon does not form an electrovalent what compound. Rather, carbon forms a covalent compound. That is, carbon has the ability to share these valence electrons with another element that has the ability to complement it. Okay, so for example, now if you look at this carbon, remember we're discussing about carbon now, this carbon now can combine with what? 4 atoms of what? Hydrogen. But in the remember that hydrogen has how many electrons? 1, right? So when it wants to combine with 4 electrons of 4 atoms of hydrogen, each of the hydrogen will attach itself to each of these, okay, such that in the process what happens? So we have a hydrogen coming in here with its own electron. We have another hydrogen coming in here with its own electron. We have another hydrogen coming in here with its own electron. We have another hydrogen coming in here with its own what? Electron. Now you see that when this hydrogen comes here, it brings in its own what? Electron, sharing it with this what? Carbon. Okay, and carbon already has 1 electron here that this hydrogen is attaching itself to. That electron that carbon has, carbon is sharing it with what? The hydrogen, such that in the process carbon balances the hydrogen, okay, and the hydrogen in turn balances what? The carbon. So in this case both of them are bringing the electrons that is being shared to balance each of them. Okay, and you know we have ordinary covalent combination or ordinary covalent bonding and what? Coordinate covalent bonding. In coordinate covalent bonding, it is both elements that are bringing what? Electrons to balance themselves. So carbon forms a coordinate covalent what? Compound, or carbon what? Goes through a coordinate covalent what? Bonding. So just as we have here, that's the same thing we also have here. That's the same thing we also have here. That's the same thing we also have here, right? So we say this is carbon, and these are what? Hydrogen. Now, with this, we have formed a compound called methane. C, that's carbon. H, how many hydrogen do we have? We have what? 4. Okay, this is what? 4 hydrogen. So this is what? Methane. Exactly. So now let's look at some properties of what? Carbon. The first property we have here is that it occurs naturally as what? Diamond and graphite. It occurs naturally as diamond and graphite. So basically, what are we saying? The natural form of carbon, the natural form of carbon is what? Diamond, is graphite. Okay, so your diamond that you know, is a form of carbon. Now, your diamond, just an introduction, is made up of what? Several carbon atoms that are closely packed together. Okay, it's made up of what? Several carbon atoms that are closely packed together. And so because of this closely packed nature, it exhibits a certain characteristics. One of which is that it is very hard. As a matter of fact, it's one of the hardest substance ever known. Exactly. Because of the closely packed nature of the carbon atoms that makes up the diamond. Are we following? Then graphite is not as hard as diamond because the carbon atoms that makes it up are not so closely packed. So there's some level of spaces that exist between them. Exactly. Then next property is that it occurs in an impure form as coal. It occurs in an impure form as coal. Then next we have it occurs in the combined state as petroleum, wood, and natural gases. So it means that carbon can occur in a free state as what? Diamond and graphite. Then carbon can occur in an impure form in the sense that you have carbon and you have other unnecessary components. Then it can occur in a combined state in the sense that you have carbon and you have other elements attached to it. Are we following now? So the difference between this combined state and this impure form is that for this combined state, you have carbon and other important elements or substances attached to it. Okay? Then for the impure form, you have carbon and other unnecessary elements attached to it or substances attached to it. Are we following now? Now, so the next is it occurs in minerals like limestone and dolomite. Okay, so you can find carbon in minerals in your limestone, in your dolomite. Then it occurs in the atmosphere. Of course, we are all familiar with that. The air that we breathe out contains what? Carbon. We call it carbon dioxide. Then it is an essential constituent of all forms of plant and animal life. In the sense that plants need carbon in the combined form of carbon dioxide to actually survive. Man also need carbon because if you are taking in oxygen and you are not breathing out carbon dioxide, it's as good as the person is not healthy, is it not so? Good. That's how I said it is an essential constituent of all forms of plant and animal life. Moving further, let's look at allotropes of carbon. Allotropes of carbon. First of all, let's understand what the term allotropy means. Allotropy is a condition. Allotropy is a what? Is a condition whereby a substance exists in different form. But this different form in which the substance exists has the same chemical properties but different physical properties. Do you get that? So allotropy is a condition in which a substance, in this case we are looking at carbon, right? So allotropy is a condition in which carbon exists in different forms. Okay, just like we have solid, liquid, and gas. So it exists in different forms. But each of these forms in which it exists have the same chemical properties. When we say have the same chemical properties, what we are saying is this: it is made up of what? Carbon. So despite the fact that the forms are different, the major component is what? Carbon. You always find carbon in each of these what? Forms. But the physical properties are different. When we say the physical properties are different, what we mean is that each of these forms do not appear what? The same. Each of these forms do not appear what? The same. So allotropy of carbon is a condition in which carbon exists in different forms, but each of these forms have the same chemical properties. Each of these forms are made up of carbon, but they differ in their appearance. They differ in their what? Behavior. They differ in their physical characteristics. Are we following now? So, we now have allotropes of carbon. Now, allotropes of carbon are those different forms of carbon that have the same chemical properties but different physical properties. A typical example of allotropes of carbon, we have diamond, we have graphite. Now, you agree with me that diamond and graphite, both of them are made up of carbon. Exactly. So they have the same chemical properties, but they don't look the same. They don't have the same value. So hence their physical properties are what? Different. Okay. Now we have here carbon exists in several allotropic forms. Now these different allotropes of carbon are categorized into two groups. They are classified into what? Two categories. You have the crystalline forms or crystalline allotropes of carbon, and you have the what? Non-crystalline or amorphous allotrope of what? Carbon. Why do we classify them into two groups? We classify them into two groups because the crystalline allotropes of carbon have a particular pattern in which their particles or the carbon that makes it up are arranged. Yes. Let's look at an instance now. So we are looking at the allotropes of carbon. Now, let's look at diamond. Now, diamond has the way it's arranged. Diamond and graphite fall under the crystalline allotropes of what? Carbon. Diamond and graphite falls under the what? Crystalline allotropes of carbon. Let's look at how the particles are arranged. Now, diamond it has an octahedral shape. So, somewhat like we have a triangle, then we have a square, and then we have another what? Triangle. This is more like a caricature of it too. Now look at the particles. Carbon, 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 carbon. Now if you check, there's a pattern in which this particle is arranged. There's a pattern. You have a triangle, you have a square, you have a triangle. Okay, you notice that the arrangement is in a repeated pattern. A triangle and another triangle again. This square also repeats itself twice again. You have this front side and you have the one at the back. This triangle also repeats itself twice. You have this front side, you have the one at the back. Remember, it's a solid. Okay, so it's a solid shape, octahedral. You have this triangle in front and you have another one at the back. So the particles of the carbon are arranged in a regular repeating pattern. That's why we say it's crystalline allotrope of what? Carbon. The same thing is applicable to what do you call it now? The graphite. So let me see whether I can draw this. Remember I said there's another one behind. We have this, we have this. Okay, something like this. So there's one at the back, there's one in front, one at the back, one in front. For the triangle, there's one at the back, which is this one. There's one in front, which is this one. Then for the rectangle, there's one in front. Sorry, there's one in front, which is this one, and there's one at the back, which is this one. The same thing with this other one. So we are seeing it now. So regular repeating pattern. That's why we said, okay, this one is a crystalline allotrope of what? Carbon. Then we have the non-crystalline allotrope of what? Carbon. Let's write this. This is a crystalline allotrope of carbon. Then we have the non-crystalline. Now, for the non-crystalline, the particles are not arranged in this regular repeating pattern. They are kind of haphazard, just like we have in gases. That's why most of the what do you call it now, non-crystalline or amorphous allotropes of carbon can actually burn. Okay, and when they burn, they form something like what do you call it now, ash. Okay, example like your coal now. Your coal, if you check your coal, is like a powdered substance, right? That when the particles are released into the air, they move in an haphazard what manner. Okay, if you check your charcoal now, when you burn the charcoal, what does it form? It forms what? Some form of smoke, right? That move in an haphazard what manner, which goes to tell you that the particles are not what arranged in a regular repeating pattern. Okay, so now let's look at diamond. Now we said diamond is a crystalline what allotropes of what carbon. So we are looking at the crystalline allotrope of carbon now, diamond. Now, what is diamond? We said diamond is the purest form of carbon. Diamond is the purest form of carbon. The diamond crystal is octahedral in shape. Is what? Octahedral in shape. So this is the octahedral shape. Okay? What we have here, this is the octahedral what? Shape. So this is the diamond. So it is octahedral in shape. Now, what is diamond? It is actually a giant molecule in which the carbon atoms are closely packed and held together by strong covalent bonds. You know, when I introduced this class, I made mention of something that carbon undergoes covalent combination, right? And the particular or specific covalent combination that carbon undergoes is what we call coordinate covalent combination. Isn't that so? So what we are saying now is that in diamond, the particles are closely packed and the force, the bond that is responsible for holding these carbon atoms together is what we call covalent bond, specifically coordinate covalent bond. Okay, now what are the properties of what carbon or diamond rather? Diamond is extremely hard. We have said that before. And the reason why we said it's very hard is because the carbon atoms that makes it up are what? Closely packed. So when we say closely packed, there is no space between each of them. Okay, which makes it a very strong what? Solid. To the point that you can't use any object to break your diamond. Also, to the point that the melting point of diamond is extremely high. So, to break the bond that exists between the carbon atoms will take a lot of heat and will take a lot of what? Force. Are we following? That's why we say that only diamond can break diamond. That means the strength of each of the diamond is in what degree? Okay, so carbon has a what high density because of its compartments of what crystal. It has a what high density. It has a high density. That is the number of particles that makes up the carbon. They are so much. They are so much that the space in which they occupied is completely what filled, such that there is no empty space between them. That's what we mean by it has a high what density. Now it is very resistant to chemical action and temperature because all four valence electrons are saturated bonded. What do we mean? Carbon does not react with chemical substance. Why? Because the carbon, sorry, diamond does not react with chemical substance. Why? Because the carbon that makes it up is already what balanced. Is already balanced. It's completely filled already. So it does not need anyone to be added to it. It does not need anyone to be taken from it. And it refuses to release anyone. That's why we said it is very resistant to chemical action and temperature. Okay, then we said it is a non-conductor of what? Electricity. Why is it a non-conductor of electricity? Remember, an element or an atom is said to be charged when it releases what? Electrons or gains electrons, right? And we have just established now that the diamond does not take in chemical, it does not involve in any chemical action. It's not affected by chemical action. It does not take in, it does not give out. So if it does not take in electrons and it does not give out electrons, that means it does not conduct electricity. Are we following? So next off, we said it is transparent and highly refractive. The diamond is transparent, you can see through it. And then when you shoot light into it, what happens to the light? The light will come out through the other side. Refractive, refraction. You know, refraction is the process whereby the light that enters into a substance, instead of it to return back to the source, it will what? Come out through the other side. Exactly. So diamond has this characteristics of what? Refraction. Okay, so that's why we use it to make what? Our jewelries and sparkling what? Substances. Now, what are the uses of diamond? They are used industrially in drills for mining. So these miners that actually mine for minerals, when they want to get these minerals, you know, they would actually need a particular machine that helps them to drill into the rock or the part of the earth that they can get that mineral, right? And sometimes these rocks can be so hard that they cannot be broken by just a mere hammer. So what do? You use diamond to cut the surface of the drill such that as you are drilling in, because diamond is very, very hard, harder than the rock itself, is able to break through so that the miners can retrieve or extract the minerals that they intend to get. And so with next they are used to sharpen very hard tools. Remember, diamond is extremely hard, so you can use it to sharp what? Hard tools. They are used for cutting glass and metals. Those people that does what? Aluminium work, when they want to cut their glass, what do? They use what? An object that has diamond coating that surface that is used for cutting to cut the glass. They are used as what? Pivot support in precision instruments and as dies for drawing wires. Now, next thing is used for making what? Your jewelries. Okay? So you see diamond used to make your ring, diamond used to make your pendant, and the rest of them. Now, that's that for diamond. Now let's talk about graphite. The graphite crystal is hexagonal in shape. Now, while diamond is octahedral, graphite is hexagonal. When we say hexagonal, hexagonal is more like hexagon is six-sided, right? So we have 1, 2, 3, 4, 5, 6. This is how your graphite looks like. It's hexagonal. How many sides? 1, 2, 3, 4, 5, 6. Okay? Carbon, carbon, carbon. So, carbon, 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 carbon. Okay? So, it's hexagonal. Now, let me show you something. This one is graphite. Now, if you look at this graphite now, this carbon here has 1, 2 attached to it. And remember, we said it can have 4, a maximum number of 4. So it's still remaining how many? 2 to be attached to it. Is it not so? That means in this graphite, there are spaces. There is need for what? More addition of what? Electrons. So there's space for other elements to be attached to this graphite. That's why graphite, unlike diamond, it conducts what? Electricity. Why? Because it still has need for more electrons to be added to it from this structure that we have here. Are we following now? This carbon now has 1, 2. This one 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 has 1, 2. Okay? So they still need extra 2 to be added to them. So they'll be able to conduct what? Electricity. Unlike this one, this damn one. Look at it. You have one here, right? And look at 1, 2, 3, 4. You see there is balance. So there's no space for any extra to be added. That's why we said that it's a non-conductor of what? Electricity. 1, 2 is very hard. 3, they are closely what? Packed. I will follow you now. But for this one, which is graphite, we have only 1, 2 attached to this, and 1, 2. And then 1, 2 attached to this, just like that. 1, 2 attached to this. 1, 2 attached to this, and then 1, 2 attached to this, and 1, 2 attached to this. 2, 2. Each of them need extra 2, 2. Okay, so we said that for graphite, the carbon atoms in graphite form flat layers. Look at it now, it's flat. So this one is not a solid what? Shape. Unlike what that one that is a solid what? Shape. More like a block form. But this one is not a block form. This one is flat, like a plane shape. Okay, it's flat like flakes. Okay, so the carbon atoms in graphite form flat layers. These layers are arranged in what? Parallel with one above the other to form a crystal lattice. Parallel. Okay, parallel. One above the other. Are we seeing it now? To form a crystal lattice. That is to form a regular repeating pattern. Now, what are the properties of graphite? We say graphite is soft and slippery. Now, where can you find graphite? You know your bicycle, the chain on your bicycle. When you touch it, it's like there's oil on it, very black and shiny, right? That shiny one is graphite. Then your pencil that you used to write, okay, you know, when you touch the surface, try to rub it off, you see some shiny black foam, right? That shiny black foam is what? Is graphite. So graphite is soft and slippery because of the weak forces that is holding the what? Layers. So each layer can slide over what? The other. Graphite is less dense. Graphite is what? Less dense in the sense that the number of carbon atoms that makes it up are very little. Okay, there are not so many, and so the spaces that are being occupied is so little. Hence we have empty spaces what? Between them. Then it is a good conductor of electricity. We have established that already because of the fact that the carbon atoms are not completely filled and they have the ability to receive more. Therefore, it is a good conductor of what? Electricity. So it's a good conductor of electricity because of the presence of free delocalized electrons. Free delocalized what? Electrons. What are the delocalized electrons? Electrons that have the ability to what? Move. Okay? So in the crystal lattice, we say it is inert and used to absorb what? Radiations. It is inert and used to absorb what? Radiations in nuclear stations. Now, what are the uses of what? Graphite? We have said this before. It is usually used on bicycle what? Chains. It is usually used on bicycle chains and for the bearings of some motor cars. The bearings, what you usually call boris. That round part that is in your tire. If you check your wheelbarrow tire now, there's a round part there that the rod used to pass through. Okay, that round part, that have all those small balls. Yes, so graphite is that substance that is used there. So it is used as a non-greasy lubricant. It is used as a non-greasy what? Lubricant. So let's put it this way. You know grease, right? That you add to any area of an iron to allow free movement. Yeah. So graphite is used as the type that is not greasy in nature, that it is not oily in nature, is used to make that type. Okay. So it is used as what? Electrodes in electroplating. So when you want to cover the surface of an iron to prevent it from rusting. You use what? Graphite. So graphite can be used to make a non-conductor conductive. Remember, graphite is a good conductor of electricity. So if you want to make a substance that does not conduct electricity to begin to conduct electricity, what do? You take graphite and what? Put it on the surface of that substance. When you do that, that substance begins to conduct what? Electricity. Now, it is used to line crucibles for making high-grade steel. Now, what's the difference between graphite and diamond? We have said that several times. Okay, we have mentioned that several times. Now, the first is graphite is less dense compared to what? Diamond. Now, the density of graphite is 2.3 gram per cm cube, while the density of diamond is 3.5 gram per cm cube. So you see that diamond has a higher density than what? Graphite. Then graphite, it is black. We have mentioned so many in your pencil. Is it not black? That's slippery substance that is shining. Is it not black? So it is black. It is opaque. That means graphite will not allow light to pass through it. Unlike diamond that is highly what? Refractive. Diamond is colorless. It does not have any color and it is what? Transparent. Then graphite is very soft and can be used to make mark on your paper. Example, your pencil now. So it means that the reason why your pencil is able to write on your paper is because of the presence of the what? The graphite. Exactly. And of course, you are very well aware that carbon is a major component of your ink that is used for printing. And carbon is present in what? Graphite. Are we following now? So now, another difference, we said graphite is very soft and makes marks on paper, while what? Diamond, it is the hardest known substance. It is the hardest known substance. Next up, graphite is a good conductor of electricity. We have said that before because of the presence of what? Electrons that are allowed to move, and because of the potential or his ability to attract what do you call it now? Other what? Electrons. Then diamond, we said it is a non-conductor of electricity because each of the carbon atom that makes it up is already what? Saturated, already has the total number of electrons that they need. So it's balanced. Then graphite attacks what? Potassium triisochlorate 5 and triisonitrate 5 acid together. While diamond is not attacked by this what? Substance. So it means that if I take graphite now and I bring it to a place where you have triisochlorate 5 or triisonitrate 5 acid, what will happen? This substance are going to what? Attack the graphite. Okay? So physical properties of what? Carbon. Physical properties of what? Carbon. So all the different allotropes of carbon are black or grayish black solids. All the different, take note, all the different allotropes of carbon, whether it is crystalline allotrope, whether it's non-crystalline allotrope or amorphous, all of them, they are black or grayish black. The only solid, the only one that is not black or grayish black is diamond. Is what? Is diamond. And also take note of this. These different allotropes of carbon, they don't have taste. They don't have what? Smell. So they are odorless, they are what? Tasteless. Including the diamond now. So take note of this. All the different allotropes of carbon are odorless and they are tasteless. 1. 2. All the different allotropes of carbon except diamond are what? Black or grayish what? Black. So it's only diamond that is not black. It's only diamond that is not grayish what? Black. Because diamond is colorless, so it's transparent. Is it not so? Now, still on the physical properties of carbon, they have a high melting point. We have said that before. They have a high melting point of about what? 3,500 degrees Celsius. So it means that, first of all, carbon is a solid. Exactly. Remember I said all of them are what? black or grayish black solid except that one. So carbon is a solid. And so if you want to melt it, it will require a high temperature of about what 3,500 degrees Celsius. So that's why we say it has a high melting point. Then carbon, they are insoluble. They are insoluble. That is, they do not dissolve in all common solvents. Common solvents like water. So if you take carbon and put it in water, it will not dissolve. If you take carbon and put it in alkalis, remember we have explained what alkalis are in our previous classes. Okay, if you take it in alkalis, if you take it and put it in alkali, it will not dissolve. Okay, if you take it and put in acid, it will not dissolve. Put it in petrol, it will not dissolve. Put it in carbon 4 sulfide, it will not dissolve. All these substances that I've mentioned, they are common solvents that will not dissolve what? Carbon, when carbon is added to them. Okay? Why? Because one, carbon has a high melting point, 3,500 degrees Celsius. Okay? So if you just put them in this solvent and leave it and you expect it to what? Dissolve. Impossible. Look at the melting temperature now, 3,500 what? Degrees Celsius. That's huge. Now look at the chemical properties of what? Carbon. One, carbon can what? Burn. Let's establish that it can what? Burn. All forms of carbon burn in excess what? Oxygen. And when it does that, what does it produce? Carbon dioxide. So carbon can burn. Carbon can burn. But it is not just in oxygen that is in little amount, but in oxygen that is in what? Excess amount. And when it does that, it forms what? Carbon dioxide. Now, all forms of carbon also burn in limited supply of air. In limited supply of air to produce carbon dioxide. What are we saying? If I bring carbon into this room, and I ensure that the amount of air that is coming in here is very small, carbon will end up forming what? Carbon dioxide. Carbon will end up forming what? Carbon dioxide. And we know that carbon dioxide is poisonous, is it not so? That's why when a person is in a room and the amount of air that is coming into that room is little, the person can what? Suffocate. Because as he or she is breathing, the carbon in that environment will mix with the little amount of air, limited supply of air, to form carbon dioxide, which has the ability to suffocate what? The person. Are we following? All right. So, when there is limited supply of air, carbon does not burn what? Completely. Okay? So now, carbon, still on the chemical properties of carbon, carbon undergo what we call combination reaction. Combination reaction. That is, you can combine carbon with another element to form another compound. Okay, so carbon combines directly with certain elements like sulfur, hydrogen, calcium, and aluminium at very high temperature to form a compound. Now, carbon can be used as a what? A reducing agent. A reducing agent. You know, a reducing agent will remove oxygen from a substance. Okay? So, carbon is a strong reducing agent. So, carbon has the ability to remove what? Oxygen. That's why we said it can be used as a what? A reducing what? Agent. So if you take a substance that has oxygen and you bring carbon, you join them together, carbon will remove the oxygen that is in that substance. Okay? That's why we say it's a reducing what? Agent. Now, carbon reacts with strong oxidizing what? Agents. Oxidizing agent is that which add oxygen to a substance. And you know, if it is adding oxygen to a substance, that means it is losing its oxygen, is it not so? So carbon will not take the oxygen. Are we following? All right. Okay. Now, the next topic we're going to be looking at is oxide of carbon. So we're going to be looking at the different compounds of carbon. Okay, the different compounds of carbon. You know, when carbon reacts with a substance, it forms a compound. So those are the different substances we're going to be looking at. Those substances that are formed when carbon probably burns in air in excess oxygen, or when carbon burns in limited supply of what? Oxygen, or limited supply of what? Air. All right, thank you very much. Do well to subscribe to our channels so that you can get more videos and get clearer understanding of different concepts in chemistry. Once again, my name is Christopher Kogome, and I'll see you in our next class. Thank you.